So good morning, it's me again. Richard sends his apologies, but as you will see, we're right in the middle of kind of a critical phase for development for Prospect, so he couldn't make it today. And I apologize in advance because I'm not an engineer, so a lot of these slides I'm going to be reading, probably verbatim. I'm going to talk a little bit today more about the hardware status and where we are within the project development for Prospect. Yesterday, I spoke a little bit about science and the science operations specifically. Having said that, the first thing I'm going to do is remind you a little bit about what we're doing scientifically. So you saw a version of this slide yesterday. On the left-hand side, you can see the goals. So with Prospect, we are aiming to land in the South Polar region to drill down into the surface to a maximum of 1 meter depth, extract the icy regolith, and pass that on to an analytical laboratory where we can run it through some spectroscopy to understand the chemistry and hopefully origin of any volatiles that we find. So looking at the volatile inventory in the South Polar region. We also have an experiment where we can demonstrate ISIU capabilities to extract oxygen from the regolith as well. So those goals were established by the Prospect science team. The development of Prospect itself is led by Leonardo in Italy. It's paid for by ESA. It's led by Leonardo in Italy, who are also responsible for the development of the proceed drilling element. So that's just the part that drills down into the surface with some additional sensors and the sampling tool as well. And the Open University is responsible for the development of the analytical package and what we call the SIS, so the sample inlet, solid inlet system, excuse me, which is the element that will transfer the sample into the laboratory and all of the gas processing systems as well. We were originally developed for flight on board Lunar 27 with Roscosmos, as I mentioned yesterday, and we had already passed the PDR stage and done a lot of detailed design against the Lunar 27 interfaces, including testing of breadboards and lots of development models. And you can see some of those images on the bottom. If you've got really good eyesight, you can see some of the labels on the bottom in the middle as well. On the left, we have a rendering of what Prospect might have looked like on Lunar 27. We don't know what it's going to look like yet for CLPS because we don't know who our lander provider is going to be yet. So we'll come to a little bit later. In the middle, you can see the bench development model for Prosper, including elements of the spectrometers and the gas processing system. And on the right, you'll see the drill model. We'll see some better images of this a little bit later. So this is what Prospect looks like conceptually. On the left-hand side, you can see an image of the drilling system, the Proceed drill system. And if I can find the pointer, you can see here, this is the drill unit Proceed, and that's basically a photograph of it. We have an imaging system, which is part of Proceed as well. So we'll be able to image the drilling and take videos of the drilling process as it advances. Here we have the central control electronics unit, rather, which controls basically everything which is happening on Prospect. And here we have the Prosper Analytical Laboratory and the SIS. And you'll see a better image of the SIS here. The SIS itself also includes, that's the solid inlet system, sorry for keep on saying SIS, also includes a camera, so we can actually image the sample once it's been deposited inside one of the ovens on the carousel, which you can see here. We have a tapping station which will seal the oven before we can heat it up and analyze the gases which are released in the laboratory. So that's basically what the system looks like conceptually. I mentioned that we were originally developed for, or developing Prospect for flight on Lunar 27. From the project perspective, we've also had to try and change quite a lot, basically, with this transition onto Prospect CLPS. So we'd already had agreements in place with NASA before we had to pull out from the Lunar 27 flight. Now we have to try and adapt Prospect for CLPS as the only flight. And operation is, I said yesterday, that's quite challenging. But from the programmatic and project perspective, we've had to do quite a lot as well. So following February 2022, we've advanced the definition of our interfaces so that we can support the CLPS procurement process. I'm going to move the microphone so that I can see it down here. I don't need to look up here. So we can support the procurement process. The industrial team have been working to reorient a continuing development. So we haven't developed from scratch. We've tried to use the development that we already had on Lunar 27 and continue that to adapt it for the CLPS opportunity. We've maintained the effort to mature the design of prospect units and the system, including the development of engineering models. And if I click the next, you'll see actually on the right-hand side here, you'll see some images of the SIS. I don't know why it's on parquet flooring, but this is images of the SIS renderings. And on the bottom here, we can see the engineering model of the drill and positioner unit undergoing vibration testing, which I think is a video. So I'll click that next. And yeah. So you'll see a short video here of the vibration testing of the engineering model of the driller and positioner. And as you can see, nothing fell off. So we were okay. The prospect science team, in the meantime, have evaluated the scientific impact, and I discussed that a little bit yesterday, just to make sure that we can actually achieve the science objectives that we were originally scoping for flight on Lunar 27. And in principle, we can, if we are lucky with the operations and well planned. So for CP22 itself, I mentioned this yesterday that we had been scheduled on flight for CP22. We were originally expecting our lander provider to be announced towards the end of last year. So last year we ran through our payload workshop where we ran through the requirements with the potential lander providers, and the selection process should have happened towards the end of last year. Then in early 2024, as we all know, we had a couple of flights, the first couple of flights for the CLPS program, both of which experienced some issues. There were partial successes, partial failures. And as a result of that, there was a reopening of the RFTOP, so the request for task order proposal. Our understanding is that that is now closed, and we would expect to hear who our lander provider is in probably late summer this year. So we're looking forward to learning that and to working with whoever is selected by NASA. The revised planning for CP22 means that we're pushed forwards by 1 year as well. So originally we were supposed to be flying at the end of 2026, beginning of 2027. Now that's shifted by 1 year to 2027, 2028. I'm going to finish up on a few slides with images of the hardware status for both Proceed and Prosper. And so for Proceed, which you can see here, we have the engineering model test completed. The first integration of the control electronics with the drill mechanical elements and the software has been done. We demonstrated the combined operations, drilling and sampling delivery, and some of this has been fed into the operations concept as well, because it gives us an idea of the amount of power and the amount of time which is required for certain operations, which has been critical for our initial plans. We started with manufacturing some parts, and that's either started or is in completion. So the actuators, carbon fiber structure already done. A unit level manufacturing integration is underway for the EQM and the FM as well. And the plan is for the integration of the EQM to start in September and for the qualification to start in spring next year. The software adaptation is under testing as well. And as I mentioned yesterday, the CDR is well underway, which is why Richard is not here. And we're focusing there. This is the prospect level CDR. We have already run CDR's critical design reviews for the individual units, which form part of Prosper. What we're looking at here is the prospect system level CDR. So how do things hang together operationally? How can we make sure that we're maintaining the right cleanliness and contamination and the volatile preservation, for example, from the science perspective? And for Prosper, I would say, first of all, if you want to know a lot more about the detail of where we are with Prosper and see some really good information about each of the different units, then there is a poster on the back there by James Mortimer, and he will be able to tell you in way more detail than I can about the status of each of these different elements. But in short, the procurement, I have a problem with that word, the procurement and manufacturing of key Prosper parts is underway. We're doing lower level testing is either underway or completed for each of the constituents of the solid inlet system, such as the tapping station, the camera, SAMCAM, and the carousel itself. The engineering model of the solid inlet system is under integration before we start the functional testing and the environmental testing. And contributions have been completed, of course, at the CDR level as well, because we're right in the middle of it. I won't go into too much detail on some of these images because you'd need incredible eyesight to actually see what they are. But basically, we have, basically here you can see the carousel. These are some of the ovens on the carousel. There's a tapping station here somewhere as well. I think that's the tapping station. This is one of the ovens. That's SamCam on the top there. So you can see each of the elements basically where we're producing hardware now. So we're really making good progress on Prospect. So to summarize, So to summarize, basically we have continued our development despite the fact we did not hear who our lander provider was going to be as we expected. So we've just continued with our development process. We focused the team on activities for completing the element and the system CDRs and making sure that we are running tests with engineering model hardware. This year is going to be very, very busy. So we'll be consolidating the interface accommodation and operational approach with our vendor as soon as they're selected and announced. We'll be doing full integration of the Prospect engineering model. So this will include environmental testing of the SIS. We're going to initiate the qualification test activities on various units, such as the drill and positioner, the control electronics units, and the Prosper system itself, and integrate everything together in an EQM for Prospect. We'll also be ramping up the operations preparations, as I mentioned yesterday. This will include a lot more interaction at the science level, so discussing with the science team. And we'll be doing some development work for the operations infrastructure and the ground segment elements as well, because this is important. Where are we going to operate from? How are we going to be integrating and working with our partners? And very, very important is that hopefully by next year, we will finally have some swag for you with wonderful Prospect logos and badges and things like that. We've been trying to get that for years. So fingers crossed, we'll get it for next year. Thank you very much.
How big is the sample that you intend to analyze? And are you expected to be adiabatic when you go on clips so that you can't dump any of your heat into the lander?
For the second part of that question, I would need to check and get back to you. For the first part, we have a very small sample. And again, the number escapes me. We are capable of retrieving, James? There you go, 50 milligrams max. Thank you very much. Yeah.
Yeah, this is Simon again. I have a question about the volatile preservation and the thermal modeling. What is the status and the experimental correlation of thermal modeling to preserve volatiles during the drilling operations?
Yeah, this is a critical aspect for us. So we've run quite a lot of analyses and experiments on this. We've done some modeling of our tolerance for volatile loss and of how much, where the volatile loss is most important, basically, how we can make sure that throughout this whole processing chain, we can maintain enough volatiles. As I mentioned yesterday, the point where we're losing most of the volatiles seems to be at the point of sample acquisition. So after the drilling, when we're actually retrieving the sample from the push tube at the end of the drill, that seems to be where we are losing most of our volatiles. We processed this through a whole modeling chain, and it seems that even with that volatile loss, we're still at well within our range and well within our rate. So we should be able to, the whole system basically is designed to maintain the volatiles, to preserve the volatiles. And from our modeling chain, it seems like we are absolutely fine in terms of preserving enough volatiles for us to get a valid result.
Prime team has a couple questions. So I saw your vibration tests for the analytical equipment, I believe. Was the drill put through vibration testing and any environmental testing?
that was the drill on the
It was a
bench.
drill. Okay, it's hard to
Yes,
see
yes,
from here.
Yeah,
So, did you do thermal cycling of it as well?
yes.
And so the cold start of the motors and everything was checked?
I believe so.
Okay,
Yes.
yeah.
Yeah.
Just where we're going is pretty cold, and the cold start is something with that we ran into. We have to get up to a certain temperature in order to get those motors to kick in. So, okay, thanks.